So, welcome everybody. This is the 15th of July, 2025. This is the Open Research Institute's projects meetup. We do mainly focused on FPGA designs, things like that. What we do in this meeting is we talk about what we have done over the past week, what we have planned for the next week. If we have any roadblocks, any problems can't resolve, need some help with, and if we need any resources that ORI can possibly provide. So to kick off our roundtable, I'll go ahead and I'm going to hand it off to Paul, who might have a brief report this week, but has also been absolutely irreplaceably amazing in support of Opulent Voice. So Paul, if you have any reports about Remote Labs West, Remote Labs South equipment, or any of the upgrade plans, the floor is yours.
Okay, well, I don't have any reports about the remote lab except it's still there, still working as far
Yeah,
as we know.
that's
Um,
working good. I've
no
used.
progress has been made on the effort to speed things up using the hardware from the other lab. We have made a lot of progress on Opulent Voice and trying to get the upper layers of user interface and so forth working. Um, I believe I'll leave that to you unless you want me to cover some of it.
I will need your help in helping to cover it, and but we'll get to that for sure in the coming right up in the agenda. So thank you so much for all of your support and hard work. The past efforts pay off every day when we're able to use all of our equipment. So thank you so much on behalf of me and everyone else involved. All right, and I'll hand the floor off to Thomas. Thank you so much for joining us. And if you have anything that you want to tell us about what you've done or what's going on over there, anything that you would like us to help you with, any roadblocks, anything at all, floor is yours.
I was also hoping that Pete would be here and share some information. So I was mostly here to listen, to be honest, because he posted some interesting things about his ideas about EVE, which I think make sense. And he was asking questions about bandwidth, which is not an issue at all. We can do this over huge bandwidth, so that should be perfectly fine. Of course, if we apply for transmit permission for Earth, Venus, Earth, it might be for a lot of power, so outside of the normal rules. And then, yeah, we have to see what kind of bandwidth would be allowed. But we can deal with it at that time. So yeah, not much else to update. We're doing another moon radar experiment on Tuesday, which is a repeat of the previous one. So we have two sets of data, but if there are any other ideas to include, and that was actually one of my questions to Pete, maybe we can hack something together and just try it. Maybe with the amplifier off, so we have a weak signal for Pete to decode. Then we still have a few days to do that, but I'll get in touch with Pete on Slack and see if we
Okay.
can arrange it.
Yeah, I know for sure that due to his travel schedule that he can't make today's meeting.
Okay.
He's thinking about or he was pretty sure about making next week. And then yeah, his so you've seen the discussion on Slack and his articles and everything. So that definitely was not thinking that he could make it today. So if you just want to connect up on Slack and maybe just think about maybe dropping by next week to talk to him in person if you don't get a chance to work out all the questions. The question about the bandwidth is interesting. So when we talk about bandwidth, it looks like a very wide bandwidth signal will give us the most traction, theoretically, practically. And the question about bandwidth is like, okay, what are the practical limitations for the equipment at the different sites that we need to be aware of? And then what's the regulatory limits which you just brought up, because yeah, there may not be a limit in terms of like the equipment or theoretical limit, but regulatory limits are a big deal, especially like you said, especially with any particular power. There's interference concerns and then regulatory issues, so they may limit the bandwidth. And then there also for very large bandwidths, we have to start looking at maybe group delay and other interesting things that happen with really large bandwidth signals. So I don't think we'll run into like the real ultra wide bandwidth group delay stuff, or if we do, then we can probably uh, kind of accommodate that. There's techniques to
Yeah.
deal with that. So
Yeah, it's an interesting question anyhow, because the bandwidth, you're actually hopping over a large bandwidth. The
yes.
instantaneous bandwidth is like none. It's a CCW, and I think the tones are really long. So the question is it really like a few hundred kilohertz, or is it just a 1 hertz signal that is hopping over the band? It's not exactly the same. And I never fully understand when something is classified as spread spectrum and when it is extremely slow frequency hopping. Where's the difference between the two?
Yeah, it's a really good question. Paul might be able to answer that. And we can also dig into that on Slack. Or if anybody else wants to weigh in on an opinion. So if you haven't read Pete's series of articles, it's in our newsletter, free on our website, and it goes out about once a month. So what we're trying to do is construct some signals for EVE, Earth, Venus, Earth, in 2026 when Venus comes around closest to the Earth again. So thank you so much, Thomas, for all the support and interaction and collaboration. And hopefully we'll get some answers on if there's any practical limits or any regulatory limits that we have to pay attention to. And then just to check to make sure that those don't impede any of the technical work or theoretical work we're doing. And then Rick's here. Rick, is there any bandwidth limitations that we need to worry about from DSES?
I don't think so. No.
Okay, good.
So we have a whole new project started up this week, so
Very good.
more confusion.
Okay, yeah, but no particular limitations on bandwidth either. That's
I
good.
don't think so, no.
Okay, thank you so much. I'll pass the word along, and we'll just proceed with what we're doing and continue to publish the work and put it out for review and get some good tests. The opportunity to test with the moon is fantastic, and that will give us a big round of confidence in terms of being able to take a risk on Venus. All right, next up is a batch of updates for Opulent Voice. This is our the digital mode that we're working on. This is our native digital mode for our satellite project for Hyperia. So this is what goes up to the satellite or goes to the repeater, the terrestrial repeater, or what we call ground sat. And let's see, Matthew is here. So what I should probably do is pause and give him the floor and see if he has any updates or any plans for working on the modem, which is what we were spending a whole lot of time on, and got to I would say a pretty decent state. And it might be happy to know that the modem with the signal has been running in the lab for weeks now, very stable and looks fantastic. So this is Locutus is the name of that particular project. So I'll give the floor over to you to talk about the modem work and maybe you can put it into context and where you'd like to go next, and the floor is yours.
And thank you. Yeah, I've not been around for a little bit, but trying to get back into things now. So as far as the modem is where I had left it off, there was some issue, and now it escapes me a little bit. But I think that there was some issue with the differential encoder and decoder. I had fixed it, the encoder, but now the receiver wasn't working. So I plan to get back into that and see if that still exists. But it's interesting that we've been working in the lab for several weeks now. My recollection was we were having some issues in the lab where we were still taking some errors of some sort. And that's why I was thinking it might be related to the differential encoder and decoder. So maybe over the next week, we can see if we think that's still an issue or not. But I would like to clean that up. So that would be my next step. And then looking beyond that, there's a number of items in the Trello list to look at. And I didn't review it before the meeting, so I can't suggest any of what they are. But there's some, well, like a lock detector for the loops, some stuff like that, just to increase the functionality and diagnostics for the modem. And then beyond that, whatever interface we need for the framing and that sort of thing. And then, I think there still probably needs to be some sort of basic modem frame, with maybe a synchronization header. And then, if there's nothing coming in, we can put in PRBS or something, there's just some, I think, integration between the what was the project you were working on at the higher levels?
Oh, interlocutor.
Right, they don't look locator. So that, interfacing those two pieces together, I think, still probably needs a little bit of attention. So I think that's it. I'm hoping to maybe spend a little time this week. We're still kind of busy with the new house and getting stuff moved over, but we'll hopefully be having a few minutes here and there to take a look at it.
Yeah, moving's big. Is the background over your shoulder your new place?
Yeah, it is. It's can't quite see the mountain, but there's a mountain back there. The lighting's not quite right. Yeah, so it's a nice place. We have 4 acres and a nice big shop building, which will need some attention. I'd like to put a lab in there and some stuff. So that'll be really nice.
Oh, well, we look forward to it, and awesome news. So yeah, the one of the things that we will be working on is to take the human radio interface part. So this runs on a Raspberry Pi and has a web interface, so that the person, the human, you can either run it on the command line, or you can call up a as pretty a web interface as we can possibly make to help you with your radio tasks. And all of this, what it does is it connects over Ethernet to the modem. So usually on a Pluto, our first target is the Pluto SDR. So get it running on a Pluto SDR. And those frames go over the wire to the modem, and the modem does a lot with this. So we're just framing up the data. We're prioritizing the data to make it a really good experience. Your voice has the highest priority. Second priority is the control messages, things that do authentication and authorization, and any sort of control or overhead channel message. The next thing down is chat, keyboard chat. So all of that's integrated. It just happens. And then data. So data files, shipping data files back and forth. And so a lot of this is working. We'll talk a little bit about what we've done over the past week with that. But the short answer, or the short summary, is that all of that work produces the data files, the frames. So these are opulent voice frames. Every 40 milliseconds, one goes out. And so the modem has a lot of other stuff to do with this. So it takes a frame and is going to do the forward error correction, the whitening, scrambling, decide to send out the preamble and the end of transmission. And like Matthew says, if nothing else needs to be transmitted, maybe it's PRBS. So similar to like DVB-S2, that you always have something active, the channel is always up. That might be a way to do it, especially with a satellite. So we'll figure that out. And Matthew, with his extensive experience in modem design and communications design and theory, will be invaluable for this sort of work. So all of that stuff, all of that part of the protocol is over there. We've looked at, we have sketched out the header, the physical layer headers, are Golang encoded, and then the rest of it convolutional encoding. We think we understand those types of encoding pretty well, and they give us decent performance. Matthew raised the idea of using spinal codes, which are fairly new. We also have an implementation to work with of LDPC, or low density parity check codes. There's polar codes that we have some folks that understand a bit about. So we have a lot of interesting forward error correction to look at and to make some decisions. Our baseline assumptions are pretty good, but they've been around for decades, and we can get some enhanced performance from using more modern codes. So that's on tap. Not the next week. We won't come back next week and have it all done, but that's kind of the road opening forward. Let's see. Yeah, I think we can probably talk about. Oh yeah, for Matthew, there's some questions from Pete. So he took a look at what we've been trying to do is write up a series of articles, and 4 or 5 of our articles have been accepted and are on either have been published or will be published in QEX magazine from ARRL. One of the articles that we're not done with yet is related to one of the Trello board. Matthew mentioned the Trello board. This is how we kind of keep organized with our tasks. But one of the tasks is to kind of document better the idea of the PI controllers, the Costas loops. So these are proportional integral controllers in our design. And these are the things that kind of help us figure out where the two frequencies are for the minimum shift keying. So Pete had some questions about, wow, there's two Costas loops. You know, his experience is that you can get away with one. And then he took a hard look at it because the write-up or the article that we worked up, so we're trying to do it from, formulas and theory. And my numbers from the article don't match the numbers that actually work in the code. And so that's always been kind of a sticking point is like, why exactly is this not working? So Pete took a look at it and he thinks that maybe because of the two different multiple clock regimes and that we may be crossing the streams there. And so that was his feedback. And he's on travel, so is not able to be here for this particular meeting, but that's what happened over the past week. So if we can kind of keep coming back to this, keep working it over, keep double checking, keep making sure that we know what we're doing. And then if we're able to explain it well in English in an accessible way, then we'll go ahead and send this article in. And that will only help us, and will also, we can say, check. We've been able to explain this part of our design, and that content also goes to the repository to explain the choices and the background on the gain numbers. So when we say gain, it's like it's a number that you multiply a value in the control loop, and if the number is too low, then you can't move fast enough to catch up. If the number's too big, then you overshoot wildly. It's unstable. So it has to be just big enough, to where you can approach your set point, without overshooting and oscillating. These are classic sort of control theory, control systems questions. And yeah, we found some good numbers that it's stable. It's working in the lab, but is it the best? And until we get we're fairly confident that numbers are really close. But we should be able to duplicate this on paper in MATLAB in simulation pretend math land. And as of today, not quite coming up with the same numbers. So anyway, hopefully over the next week, we'll be able to dig in and kind of figure out where the paper went wrong, what it's not appreciating in the code, or if there is some sort of clock thing, or that we do have a factor of 25 in there that may not be properly reflected in the paper. So we're going to keep working on that and come up with a really good explanation. We do know that the overall design of the article has gotten really solid positive reviews. QX would like to publish it once we get more confident that the numbers reflect the code base. So that's the news about that. Let's see. We have a lot of work to report about Opulent Voice on the human radio interface. This is a code base written in Python. So these are a set of Python scripts. And the Python scripts, if you want to, as an argument, you can call up a web interface. If you just call them, then you get a command line interface, a terminal interface. And this interface is with you, the human. So you have a chat, keyboard chat, and a microphone, headphone. And then you can also send and receive files and control information. Over the past couple of days, we have figured out a COBS, or a constant overhead byte stuffing issue, and solved it. So that's kind of a big deal. It's been kind of nagging us for a little while. What COBS does is it tells you when the beginning and the ending of your information is. So we have fixed frame lengths that go out every 40 milliseconds. And what we did is we sized those frames for audio. So the 80 bytes of Opus audio payload, and then add all the headers, and that's the number that we need to use for text, for control, for data. And we did not have that quite right. We also had kind of I had a misunderstanding on the delimiter versus the overhead packet for COBs. So sorted out, took some effort, and it's now working really well. The next big step over the next day or so, week really, is to get audio working in the web interface. The web interface, text chat is working. A lot of stuff is working. Configuration, file management working. Lots of nice things are happening. The command line interface, you can hear test tones in the headphone, but you can't hear audio yet. And chat's working, and all the configuration stuff is working. So getting audio working, that's going to bring us up to a level where we then are going to ask people, please try our software without a modem, chat back and forth over the internet like it's a chat program, like it's essentially a lightweight Discord. Tell us what we need to change in terms of the user experience, user interface. We test how accessible this is for visual, hearing, challenges, mobility challenges. We want it to be as accessible as possible and useful as possible. So we're very close to that step. Integrating the modem in will take some work. We're going to be delivering the data, essentially over Ethernet. So we say what our target IP address is, and the Pluto is going to have to take that data stream and then do something with it. So Matthew will probably have to update the code to where the source of the data files are coming from an IP address. So that's the next big step on both our sides. Okay, any questions about Opulent Voice or the radio interface or the code base or COBs or anything, or the modem? Anything that I missed? I know that there was a lot of earlier work since we last talked about the COBs wasn't the only thing that we worked on. Paul, you got something?
Yeah, I just want to make one comment about what you were just saying about asking people to test it over the internet. Um, we're able to test it over the Ethernet here because we're local, so there's very few disruptions to packets going from interlocutor to the uh, device playing the role of the modem, which is another interlocutor or possibly postlocutor in one of our test environments. Um, but if you're going to ask people to test it over the internet, it's going to have to be more robust to the kinds of things that the internet does to your data. So we'll have to switch to a different encapsulation mode to make it reliable for those people. And that'll be some work that has to get done before that can get thrown out to the crowds.
Okay, that's true. We did talk about this, and it's captured in one of the issues. So thanks for bringing that up. Do have to take some care. Maybe people could test it if it was on the LAN. That'd be pretty safe.
Yeah, if you have two enthusiasts who happen to be within land distance of each other, then that's very feasible with the current implementation. But I'm guessing enthusiasts might be a little thinner on the ground in most places.
Yes, I'm thinking intercontinental might be the case because we have some very enthusiastic folks from JamSat that would really like to see this, and it's and some enthusiasm from Germany as well. So yeah, okay, that's good. At least we know what we need to do. So I definitely want to get the audio working and solid and the way that we want it. With the what you should see is you should hear audio in your headphones live from people talking to your station. You should also see in the interface a little bubble about an audio message and from the station and how long that transmission was, and you should click on that and be able to hear it played back to you. So you can wander away and then come back and catch up with the audio transmissions. Now, it won't store everything forever. We're going to have to come up with some sort of limit and they get dropped off the other end. But this sort of interface got huge positive feedback when we talked around about it, because what it kind of does is it lets you have a station where it's not just, oh, you didn't hear the transmission, too bad. And also it kind of lets you, if you can like turn off your speaker, but you can still listen to audio maybe through later, and you can still communicate over chat. So, and also the accessibility rating on this was really kind of high. Accessibility at the core is about having multiple ways to get at the same data. It's one more step after that to add a live transcription so that people that can't hear or cannot have audio wherever they are, or can't be present live, will have not just the audio to hear later, but also text transcription of the audio so that if you can't hear, you're not left out. So that's kind of the goal, is to provide all of that in the web interface, and we're pretty close. So within the next couple of weeks, hopefully we'll have this ready to test, like actual people that have not been sitting with it for weeks on end. We need that sort of feedback as early as possible, but we don't want to give them something that's super broken. So it is kind of a balance, like it needs to be good enough to hand off to you, but still early enough in the process to where any of the decisions that we've made, if they're bad for accessibility or bad for usability, that we can correct, without too much technical debt. Let's see. Okay, that's it. That's all I've got for that. I have an update from Ed Friesma. He's working on photogrammetry. And this was originally a question from DSES about how do we really figure out the variability of our dish surface, the root mean square variability of a dish surface for microwave or for radar, the variability from a perfect parabola or some other perfect curve, elliptic curve, or whatever you're using. That variation is the RMS value, which goes into the Roos equation for loss of, or for system noise temperature. And system noise temperature determines a lot about your performance of your antenna. And so this arose. It was like, well, how do we measure this? And there is a way to measure it. There is a way to get in software a surface, like, okay, here's the real surface using photography. And this is really neat. So you have a bunch of markers that you scatter around on your surface, and you have to get them close enough to where it matters, but not so close that it's really overwhelming for the software. So put in a bunch of ping pong balls or QR codes or, Post-it notes or whatever. Take a bunch of different pictures from different directions. For a dish, you may want to consider a drone. But for a lot of objects, you can just walk around it and take lots of photographs, digital photographs, and then feed it through software or a script. There's at least 4 or 5 different software packages, and then it will produce a mesh of that surface. So you can get a 3-dimensional surface, a mesh in software. And from then you can say, okay, if I had a curve fit, a parabola, what's the RMS difference? You feed that right into the Roos equation. The reason is because the reason for all of this was DSES folks were seeing a big discrepancy between what they should be receiving and what they were receiving for known good targets. And so we really want to help. And so Alex over at DSES, he has all this information and has a target, a dish in his backyard that's pretty big, like 4 feet or bigger. And he's going to try it out on that dish and then put together a work party to go to DSES and to map out the dish to make sure that it's they understand what the shape is. And then Ed, he decided to do his car. So he put ping pong balls all over his car, and he's grinding through, learning how to use. So he wrote some code to do this. So pretty soon he'll be able to give us, like, here's how you do it, maybe a workflow. We'll publish that as an article and hand it over to DSES so that they have yet another option and a reference for how to do it. So in between Ed and Alex and others, I think that we'll be able to get an answer, at least to be able to tell, okay, is the surface of DSES dish the way that they expect it? It shouldn't vary by very many millimeters, but this dish has been up for quite a while, and it's exposed to some high wind speeds and some big storms. So we'll see. This is very exciting. We're very happy to be able to help, and also to help in an inexpensive way, for the cost of putting a drone up with a enough of a good camera. This is the GoPro territory, really, or even cell phone territory. To put up a camera and to get a whole bunch of different photos, and then any sort of noise or inaccuracy kind of averages out, and you get a mesh and you can look at it. So get a high resolution camera up and around the dish, lots and lots of photos, and we'll get an answer. And that'll help. We'll put that right into our link analysis budget and get some good numbers. So moving forward, we have let's see, and then there's a FCC Technological Advisory Council meeting coming right up. It's in early August, and we are moving forward with all of our recommendations. Our particular part of that is the dynamic spectrum sort of so dynamic allocation of spectrum or advanced spectrum sharing is kind of where we're contributing. And we have been able to come up with some recommendations on how to sort of like address maybe some areas of weakness in the current regulatory model. So we have some modest recommendations on and pointing out where the successes are currently in dynamic spectrum allocation or advanced spectrum sharing to be able to move things forward. And we wrote a defense of the amateur radio service and how we do it, and also how things work in the amateur radio satellite service. The area of interest for this particular item was terrestrial and satellite. And so there's been lots of work there that we've been trying to help with. So this will be the last meeting of this particular session. Our mandate or our charter closes in September of 2025. So if there is a new Technological Advisory Council set up for the next 2 years, then I will let everybody know as soon as I know anything. It's been an honor to be able to contribute and serve. We've helped with the 6G subcommittee or working group, and also with spectrum sharing. There's also an artificial intelligence working group. And the previous session, we co-chaired that one and contributed a couple of recommendations that at least one has been adopted by the FCC. So good news on that, with the exception of no news on whether FCC TAC will continue. So that's what we're kind of waiting to find out. All right, another regulatory item. This is the final item I have from the agenda. This is via Justin, AB3E, and he reports. Let me just read from what he said. Okay, ARRL, the Amateur Radio Relay League, had a meeting with the WTB, and that's one of the bureaus, so wireless bureau of the FCC. Whenever you meet with the government, then you have to file what's called an ex parte filing, a notice. You have to disclose what you talked about. And ARL, of course, did. And Justin posted the link to that particular notice, that summary of their ex parte meeting. This meeting was about the delete proposal, notice of proposed rulemaking, or a call for contributions. We participated in that in several ways, and the basic idea behind that was, hey, is there anything that should be just simply deleted from the regulatory pantheon from the FCC regulations? And there are a lot of outdated, obsolete things. Any set of regulations that has been around for decades has that sort of stuff. So we filed a pretty substantial 219 megahertz opinion request for particular actions to be taken. ARL didn't mention that in particular, but they did talk about the need for an omnibus proceeding to update the amateur rules. So what we're kind of looking for, since there has been one update about the delete stuff that's come out, it looks like what's happening is that all of these delete requests were taken, weighed, and considered, and that the FCC is now sort of rolling out packages of things, batching up the stuff. And there was a lot of amateur radio content that was submitted for delete. So ARL is helping to kind of get out ahead of this and to say, hey, it looks like that you could also have an omnibus proceeding about the amateur rules. So Justin suggests that we get in touch with the ARL. And since they've been generally supportive of our efforts, very helpful, and specifically supportive of the 219 megahertz work, that if we could possibly work with ARL to maybe make some suggestions or to reiterate these specific suggestions for an omnibus, that might be a good idea. So we'll try to do that as soon as possible. We've also been asked about another amateur satellite issue from AMSAT UK that we are absolutely going to follow up on. So that is a different frequency band, but we've been asked for help with that as well. Also, ARL called out for a handful of rules that would be good for what's called the direct final rule process, and that include the removal of this remaining symbol rate limits. So we really liked seeing that as well. All right, that concludes the agenda that I have. It's now open to anybody that has anything that they'd like to discuss or any questions that anybody might have. All right, we'll conclude the recorded part and then have open office hours. And